Hello everyone, welcome back in the next video in this series of linear algebra question which are asked in the GATE exam in the previous year. So let's start with this video with this question. So question 1 says if we have a matrix A with the order of this 3 cross 3, then what is the A inverse of this matrix? So now first of all, to find the inverse, recall the formula for any inverse of a matrix. So I have to put the determinant in the denominator, and I have to multiply this with adjoint of matrix A here, and here there are the some specific step to find the adjoint of any particular matrix. So now first of all, to find the inverse, we need the value of determinant. So let's do it here. We have to find the determinant of this matrix here. So let's what I'm getting here, 5 multiply with 3, so I can write 5 times 3 plus 2 multiply with minus 6, so I can write like this, 15 minus 12, so I'm getting the determinant as plus 3. So now I have find out the determinant, so let's put it here. So 1 by 3 multiplied with adjoint of A, A will give me my inverse. So now here to find the inverse for this MCQ type of question, we do not need to find the whole matrix, because here if we find some specific element and we compare from this option, we can say which one is the correct one. So now here let's first of all find the, now to find the adjoint, remember three steps. First step is that we have to find the minors of this all entries. We have to find the minors of this a11, a12, a13. In the same way, we have to find the all the minors, and here we are getting a 9 minors because the matrix is 3 cross 3. So we are getting the 9 number of minors. So now from this minors, I have to form the cofactor, and I have to put the cofactor here at this place. For this 5, I have to first of all find the minors of this 5, and I have to put this minus here at the place of 5, and then I have to make its cofactor with the multiplication of this factor, minus 1 to the I minus 1 to the power I plus j. So now after that the last step is that we have to take the transpose. So now this this row, first row will become first column, and first column will become first row of adjoint matrix. So now let's this elements is remain at this place for this a11, because if you flip this row in this first column, then this element is remain as it is. So first of all, let's find the minors of this first element, and here it is 5. So let's represent the minors of 1 as a11. So now I have to make the determinant of this minors of 5 in the form of this 2 cross 2 matrix. Here it has entry of 3 0 0 1. So now simply the minors of this 5 will be plus 3, and now let's find the cofactor, and I am representing as C11. So I have to multiply this 3 with minus 1 to the power of 2, because here I and j has value 1 1 respectively. So I have to edit this 2, and I am getting 2 here and multiplied with 3. So again I am getting plus 3 as the cofactor. So now I can say the first entry in this adjoint matrix will be 3 here. So now you can see from the option B will cancel out because it has 1 by 5. Option D is also cancel out, and option C is also cancel out. So in this first step we are reached at our answer. So now for further clarity, you can also check for other elements. So let's check for this element here, because you can see the entries are all different for all the four option. Here we have minus 2, here plus 1 half, and here minus 1 half, and here plus 2. So now let's find the first of all minors. So now we are interested at this place in this adjoint matrix. So now we have to find the minors of this one, this element in this original matrix, because after the cofactor matrix we are taking the transpose, so this element will goes to here after taking the transpose. So to find this element in this inverse matrix, we have to find the minors of this number, exactly the opposite in this diagonal place. In the same way, this one and this one. So now we are interested in this value in the inverse. So I have to find the cofactor of this one, and it has an address of A31 because it is present in the third row and first column. So again, let's form the minors of this element. So I can form the 2 cross 2 matrix like this. Let's find the determinant. Here I am getting -6. Now let's form the cofactor matrix, and it is represented as C31, and C here stand for the cofactor. So now I have to multiply it with -1 raised to 4. I have to add these two number, and it will give me 4. I have to multiply it with -6. So again here the power is even. So I am getting the -6. So I have find out the cofactor. So let's put this -6 here. Now look at the option. Here option in the option A is given the -2. So now let's multiply this 1 by 3 factor inside of this matrix. Do not forget this factor here 1 by 3. So now if we multiply 1 by 3 with this -6, so I am getting -2 here and here 1. So option A has the correct this two value in the same way. So option A is the correct inverse for this 3 cross 3 matrix. You can also check for the remaining entries. They are still the same as this given in the option A. So option A is the right one. Now let's solve question number 2. Question 2 says the characteristic equation of 3 cross 3 matrix P is defined as alpha of lambda. Here they have formed the this determinant, and they have given the characteristic equation in this form of in this polynomial form. If I denote the identity matrix, then the inverse of matrix P. Again here we have to use the Cayley-Hamilton theorem because we have given the characteristic equation for this matrix P, and they are asking about the inverse. And look at the option. The option are given in this form of polynomial, and here the matrix P is written in this place of variable in this polynomial. So use the again we have to use Cayley Hamilton theorem to find the inverse in this polynomial form. So what Cayley Hamilton theorem says that, let's write it here. Every matrix sorry for my handwriting. So now statement says that every matrix satisfies its own characteristic equation. So now here with the help of Cayley-Hamilton theorem, I can replace this lambda by the P because the theorem states that every matrix satisfies own characteristic equation. So let's replace with P in characteristics equation. So now here I can write like this: P to the 3 plus P square plus 2 times P plus 1. Here sorry, not 1, here I have to make the identity because I am going in this matrix form from this polynomial. So I have to replace this this 1 with identity matrix in this matrix notation, and right hand side also we have 0. And but here recall this 0 is not here, it is not scalar, but it is in this form matrix form which all entries are 0 like this. So here the right hand side is in this form 0 0 0, and it is again we call it zero matrix. So now we have find out the equation in this form. So now they are asking about the inverse. So how to find the inverse from this equation? So now the next step is that we have to multiply this equation with inverse. So let's write it here. Multiply with P inverse. So let's do it here. If I multiply here, so I am getting here P square, here P, here 2 times identity matrix, and here P inverse, and the right hand side is again 0 as it is, because multiplication of any matrix with 0 matrix still gives 0. So now let's make subject this P inverse. Let's bring these three terms on the other side. So I can write P inverse is nothing but the negative of this polynomial P square plus P plus 2i. So now I have find out the inverse in this polynomial form. So now look at the option. Option A has the correct polynomial, but here the sign is plus, so option A is not correct one. Option B is also not correct one. Option C describe the inverse correctly as the same as this one, because look at the here we have minus sign, here we also have, and p square plus p plus 2i. So the exactly the same equation that we have got here. So option C is the correct inverse of our this P matrix, which is order of 3 cross 3. Okay, now let's solve question number 3. Question 3 says if a rank of 5 cross 6 matrix Q is 4. Okay, we have matrix Q. Let's we have matrix Q, and it has an order of 5 row and 6 column, and it is given that the rank of Q is 4. So let's write it here. Rank of this Q matrix has value 4. Then which one of the following statement is correct? Okay, so we have 4 statement. Let's check option A. Option A says Q will have a 4 linearly independent rows. Yes, it is the correct, because the rank is nothing but the number of linearly independent rows or number of linearly independent column. So rank is nothing but what is simply denote the rank is number of linearly independent. Here the Li means linearly independent row or column. So now option A says Q will have 4 linearly independent row. Yes, it's the correct, and 5 linearly independent columns. Now here we are we have a 4 linearly independent rows and 4 linearly independent column, but the option A says 5 linearly independent column. So option A is wrong. Option B says Q will have a 4 linearly independent rows and 4 linearly independent columns. Here I have to put rows and columns. So now option B says it has a 4 linearly independent rows and column. Yes, it is the correct, because the what does it mean that rank is 4? It just simply has meaning that the matrix has 4 linearly independent rows and 4 linearly independent column. So option C is the option B is the correct one. Now again option C is not always hold. Q transpose times Q will be invertible. We are not sure. And again here Q multiplied with Q transpose will be invertible. So now we have reached the conclusion that only option B is the correct one for this question. Okay, now let's solve question number 4. Question 4 says A is M cross N full rank matrix with M has a dimension greater than the N, and I is an identity matrix. Let's A to the plus, here A plus, it is defined in this way. Then which one of the following statement is false? Okay, so they're asking about the false statement. And here the condition I'm given about this matrix A. So let's write it here. Matrix A has a dimension of M cross N. It has M rows and N column. And here it has full rank. In the other word, it has rank of N rank of A is n, because we have to choose the from this two number, minimum number we have to choose. In the case of full rank matrix, full ranks means the matrix has not rank deficient, it has maximum rank it could have. So now the rank maximum rank for this matrix is n, because remember basic concept, rank of any matrix is must be less than or equal to minimum of its dimension. Here the dimension are m and n. So now minimum of this two number is n, so rank must be less than or equal to n, but here it is given that a matrix is full rank, so I can say the I can uh, ignore this less than sign and I put the equal to, and I can say the rank is exactly same as n, then and then it will have full rank. So now let's move to the option A. Option A says if I multiply this A plus with A, then in the output I am getting identity. So now the A plus is defined in this particular way, so let's put it here. Let's check for the option A. So I can write here we are checking for option A. So let's replace this A plus with this whole term. So I can write here A transpose multiplied A, I have to take the inverse, I have to multiply it with transpose, and now again I have to multiply A from this A here, and I have to resolve it, and if I get the identity output, then this condition is true, but they are asking about the false condition, false relationship. So let's first of all apply this inverse with this bracket. Now if I am applying this inverse with this bracket, then remember we have to flip the sign, sorry, flip the word, flip this place. A transpose will come here and A will come here, so I can write like this: A inverse multiplied with A transpose, and I have to take the inverse also. I am applying inverse to this two individual matrix, so I have to reverse the order. This A will come at first and I have to take the inverse, and this A transpose will go to the place of A, and again I have to take the individual transpose of these two, and here we have already A transpose there and A as it is. So now let's simplify further. So now here the matrix multiplied with its inverse, here the matrix is A transpose and its inverse, so it's give me an identity matrix. So let's reduce this term with identity, so I can end up with this term A inverse multiplied with A. So now again you can see again the matrix is multiplying with its inverse, so again it's give me an identity matrix, so I am getting the right hand side. So option A is the correct statement and it is not the answer for this question. So now let's move to the option B. Remember we have to find the wrong relationship. So now option B says if I am multiplying this A plus with A on the left hand side and right hand side, then in the output I am getting the A. So now here recall from this option A, this A plus times A gives me identity, so let's directly replace this term here with identity, because we already have proven it that this one is true. So let's replace this term with directly identity, so I can write A times identity, it's again give me a matrix A simply. So again option B is also true and it is not the answer for this question. So now let's move to the option C. Now again option C says A multiplied with A plus whole square. If I am taking the at square whole square, then it is exactly same as A multiplied with A plus. So now this will look like little bit complicated. So first of all let check for the option D. Is option D is also correct one, then the automatically C is the wrong one. So let's check for the option D, because it's look like very similar to this one. So now let's again replace this with the help of with identity from this option A, because option A is true, we have proven here option A is the true relation. So let's replace again this with identity, so I can write like A times identity and it's again give me A, but here in the option D they have written on the right hand side as A plus, but I am getting here A, so this relationship must be false. So option D is the correct answer for this problem. So now let's also check for the option C for understand the concept better. Let's do it here for the option C. Okay, we have to multiply this matrix A multiply with A plus. So let's write A here, and again let's expand this inverse apply to this individual. So I can write like A inverse times A transpose inverse and A transpose as it is. So now let's multiply these two. So again here I am getting identity from the multiplication of matrix and its inverse. So here what I am getting, A transpose inverse multiplied with transpose. So again the matrix is multiplying with its inverse, so it's again give me an identity, and I have to take the square. So let's square it. So again I am getting the identity matrix, but here in the right hand side they have written A multiplied A plus. So I have to also find out what this A multiplied with A plus gives me. If it's give me an identity matrix, then this condition is true. So let's find this one also. So here matrix A as it is, yes, it is also giving me identity because here it is the exactly same. I have proven this as an identity, and I am taking the square of this. So this one is nothing but the identity, and if I am taking the square, then again I am getting the identity. But here on the right hand side they have not write the identity matrix, but they have put this simply as it is. But here this is nothing but the identity matrix again, but it is in the hidden form. We have proven it. This is nothing but the identity matrix. So we can say yes, it is the correct statement, and it is not the answer for this question. So the only option D is the answer for this question. Okay, now let's move to the next question. Okay, now let's solve question number 5. Question 5 says eigenvectors of a matrix. Okay, we have a 2 cross 2 matrix are written in the form A 1, and here A unknown, and 1, and here again B unknown. What is the value of this addition of these two unknown A plus B? So first of all we have to find the eigenvector to get the value of A and B here. So simply we have to use the concept like this concept Ax equal to lambda x. Here the matrix A is given and X is also given, but here we have unknown A here. So let's try to find out the value of A first. So let's write the matrix as it is here. Let's multiply it with this first vector which is value 1 comma A. Let's do the multiplication. So here I am getting 1 plus 2A, and here 2A. So now if I bring 2 common, then and then this entry and this entry will exactly same, because I have to we have given that this is the eigenvector, and this vector must be represented in this form m lambda times x. So let's select the lambda here is 2, and so I can make this a, sorry, this 2a is a, which is exactly identical as a, and here at this place what I am getting is just 1 half plus a. If this condition, if this entry is exactly same as this one, then for the this entry is also exactly same as this one, so I can equate this 1 half plus a equal to 1. So let's equate, because these two these two values are exactly repeating here, this in this form ax equal to lambda x. So I can say 1 half plus a will give me again 1. So I can say the value of a here is 1 half. So I have find out the value of a here unknown, a which is unknown. So now in the same way I can also find the value of b. So in the same way let's write the matrix a here as it is. Let's multiply it with this vector. So now again do the same thing, 1 plus 2b, and again here 2b. So now again if I want to represent this factor in this lambda times the initial one. The initial one is here, initial one has entry b. So I can see if I take the 2 common, then I will make this 2b as b, and which is exactly identical as this one. So now here again I am getting 1 half plus b. So now again equate this 1 half plus b equal to 1. So again I am getting here b is again 1 half. So I have find out this two unknown a and b, and it has value of 1 half. So they are asking about the addition. So I have to just simply add these two number and it will give me 1. So the summation of these two unknown is 1. So option D is the correct one. Okay, now let's solve question number 6. Question 6 says, for what values of a, if any, is there, will the following system of equation in x, y and z have a solution? So we have to find the value of a in such way that this system is at least consistent. So now first of all we can write this equation in this matrix notation like ax equal to b. From this we can form the augmented matrix. So now let's quickly form the augmented matrix. So I have to write the coefficient here for the first equation here 0 1 1 1 1 2 and minus 1, and I have to write the right hand side here. So it has value of 4 4 and alpha. So now certain alpha we have a unknown here, sorry, here we have a which is unknown, and that's value we have to find. So now the system is have a solution. Now the system have solution in two way. Either the system has there are two way for solution. So let's write it here. Either the system has a unique solution, either system has a unique solution or infinite solution. So these are the two way to system have a solution. So now for the unique solution, what is the necessary condition? The necessary condition is that the rank of this cofactor matrix here, this one 3 cross 3, and the rank of this augmented matrix which is order of 3 cross 3, 3 cross 4 are the exactly same, and which are the number of unknown, and the number of unknown here is 3. And the for the case of infinite solution, what we have, what is the necessary condition is, it is that uh, that we have a rank of this cofactor matrix is exactly same as the rank of this augmented matrix, but the rank is less than the number of unknown, and here the number of unknown is 3. That means the matrix is, if the matrix is rank deficient, then we have infinite solution, and if the matrix is full rank with the full rank, then the system has a unique solution. So okay, so let's first we have to what we have to do is just apply some row operation to reduce this matrix into echelon form. So now we have to perform some row operation and we have to reduce this matrix into echelon form. So I have to make this entry as 0 and this as 0. So now the we have to do the operation. Let's subtract this first row with this third one. So R3 minus R1 will make new R3, and I have to subtract this first row with this second. So R2 minus R will make row 2 second row. So now let's do these two operation. So here the first row will remain as it is. So now here this entry will 0, here minus 2 1, again here 0, again here 0 minus 1 minus 1, and here a minus 4. So now to further reduce this matrix, what we have to do, we have to make this entry as 0. So now the next step is that we have to add, we have to subtract this row multiplied with 1 half from this third row. So I can write like this: R3 minus R2 by 2 make new R3. So now after this step, what we are getting? Let's write it here. So the first row will remain as it is, 3 0 4 1, and the second row is also remain as it is, 0 minus 2 1 0. Now here we already have 0. Now here I am getting plus 1 because dividing these two minus 1 and multiplying with minus, so it will make plus 1, and let's add this plus 1 in this minus 1. So here I am getting 0. Now here I am getting minus 1 half. We already have minus 1 here, so we have to subtract this one. So here I am getting minus 3 by 2, and here we went to 0, so this a minus 4 will remain as it is. So now if you check for the rank of this coefficient matrix, here it has entry of 2. So now let's write it here: the rank of coefficient matrix, it has rank of 3 because 3 number of linearly independent rows or column which are present in this matrix A. Here I am talking about this 3 cross 3 matrix. It has an order of 3 cross 3. That means it has a full rank, and if the matrix has full rank, then there is a unique solution. So now the rank of this coefficient matrix is 3. So now let's also find the rank of augmented matrix. So now the augmented matrix has an order of 3 cross 4 because it has these 3 rows and 3 column, sorry 4 column, so it has order of 3 cross 4. And now again look at the number of non-zero rows or columns. So here we have reduced this this matrix in the echelon form. So the number of non-zero rows are 3. So the rank of the augmented matrix is also 3, and which is also has a full rank because the rank is the minimum of these two number, and the minimum is 3 here, and the rank is must be less than or equal to this 3, and the here the rank is 3. That's mean it has a full rank. So now for the any value of a here, this entry here will be non-zero. So in the other word, this last row will we cannot make as for full as in 0 0, like this all entries are we cannot make like this for any values of a. We can make this entry as 0 by selecting a as value of 4, but this entry will remain as it is irrespective of a here. So this entry is not going to 0 for any values of a here. So that it means that the rank of augmented matrix is 3, and it is not affected by the any values of a here, and which is unknown. So the conclusion is that we are getting the solution for this system for any values of a here irrespective of a. Whatever value may have a have take here, it the system is always consistent, and it always gives a unique solution. So we can say the system has a solution for any real number for this a here. So a can take any real any real value from this r. So a belongs to r, and still the system has the solution. So option D is the correct one. Now let's move to the next question. Okay, now let's solve question number 7. Question 7 says the matrix A, here we have A, and which is 2 cross 2 matrix, is decomposed into a product of lower triangular matrix L and upper triangular matrix U. The properly decomposed L and U matrices respectively are. Okay, so we have matrix A here. Let's write it here. We have matrix A, and it is decomposed in such way that the multiplication of this lower triangle and upper triangle gives me the matrix A. So I can write like this: this matrix is decomposed in this multiplication of these two matrices. Here the L represent lower triangle, and this U represent an upper triangular matrix. So now I have a matrix A which is given in the option, sorry, a question. It has value of 2, 1, 4 and -1, and I have to find the this upper triangular and lower triangular matrix. So now here the conventional method is that this one is the lower triangular. That's mean all the entries above the diagonal are 0. So this is the diagonal. So it is also again a 2 cross 2 matrix, because here the matrix is 2 cross 2. So this L and U is also 2 cross 2 matrix. So here I have entry 0 and it is an upper triangular. So here this entry will 0 and these entries are non-zero. Here, here and these 3. But now we can generally assume this entries, and any here we have assume either 1 1 and here we have uh, assume any general variable. Let's call it A and B, C and D here, and multiplying these two matrix and equate this element with this one after multiplication, and this with second one, this with third, and this with fourth one. So now here it is the lengthier procedure, because this for this types of question we have less time in this examination. So now what we have to do, we are going from this option. Simply we have to multiply these two matrices and we have to check either we have getting this matrix A or not. But here we do not have to multiply it as full, because if we multiply this first, we are finding the first entry in this after the multiplication. If it's give me a 2, then and then I proceed for the next entries, otherwise I move to the next option. So now let's start from the option A. So option here A has matrices like it has value of 0, 2, 4, -1. It is a lower triangular, and upper triangular matrix has value of 1, 1, 0 and 1. So now let's do the multiplication and let's find this first entry. So this first row multiply with this column. So here I am getting 2 here. So now you can see which is exactly same as this entry here in the original matrix A. So yes, this first entry is the correct one. So now let's proceed for this next one. So let's multiply this first row with the second column. Again here we are getting here 2, because this 2 will multiply with this one and 0 with 1. So again 2. Now look at the matrix in the question A. It has value of 1, but here we are getting 2. So automatically option A is not correct set of upper triangular and lower triangular matrix which are decomposed in the proper manner. So option A is wrong one. Now let's do the same thing for the option B. Let's find the first element in this option. So here I am getting the first element as 1, because this first row here multiplied with here. So this 1 with multiplied with 1, so 1 plus 0 multiplied with 0. So I am getting 1 as first entry, but here we have 2. So again option B is wrong. So now let's do the same thing for the option C. Again let's multiply this first row with first column of this upper triangular matrix. So yes, first entry in this multiplication is 2, because this one with multiply with this 2 and here we are getting 0. So simply 2. Let's find this second element. So multiply this one with 1, it will give me 1 plus 0 multiply with -1, so it's make 0. So again simply I am getting 1 here. So yes, this first row is exactly same as this one. So now let's move to the next step. 4 multiply with 2, so 8, and here 0. So I am here getting 8. But now here we have given the 4. So option C is also not the correct one. So the only remaining option is D, and which is of course correct one. But now let quickly also do the multiplication of these two here for the option D also. So here the first entry is again 2, because these two multiply with 1. Again here I am getting 1, here I am getting 4, and here 2 minus 3 again is 1, which is exactly same as this matrix which is given in the question. So these two matrices are the proper set of lower triangular and upper triangular matrix which are decomposed of decomposed of this matrix. So option D is the correct answer for this question. Now let's move to the next question. Okay, now let's solve question number 8. Question 8 says A is a square matrix which is neither symmetric nor Q symmetric, and A transpose is a transpose. The sum and difference of this matrix are defined as, okay, the sum is defined as S and it is written as A matrix plus its transpose, and the difference D is defined as A matrix minus its transpose respectively. Which one of the following statement is true? Okay, so they're asking about the this matrix S and D. So now here A is any general square matrix and it is neither symmetric nor skew symmetric. Okay, so now the we have one concept that we can represent any square matrix as the sum of symmetric matrix and skew symmetric matrix. For let's say here any matrix, any square matrix, any square matrix can be represented in the form of symmetric matrix, symmetric matrix plus skew symmetric matrix plus skew symmetric matrix. And here this symmetric matrix is nothing but simply just A. Let's call here the matrix we have is A and it is any general square matrix. So A plus A transpose by 2 plus A minus A transpose by 2. So this one is the symmetric matrix, this one is symmetric, and this one is skew symmetric. So now here the S is defined as 1A plus A transpose, but here the factor of 1/2 is missing, but it does not make any difference because the any multiplication of scalar does not send the matrix from the symmetric to Q symmetric or Q symmetric to symmetric. It's remain the as it is. Either the matrix is symmetric, then the after multiplication with any scalar it is remain the symmetric or remains Q symmetric as it is. But now here the 1/2 factor is that it placed here for to satisfy this left hand side to give is again A. If you simplify this one, so this 1/2 plus A transpose and minus 1/2 A transpose will cancel out, and this 1/2 A plus 1/2 A again will give me a initial matrix A. So that's why the factor 2 is placed here. So now in the general way I can say if I add the transpose of any matrix, any square matrix and its matrix and the original matrix, then it will give me a symmetric matrix. And if I subtract the transpose of any matrix from its matrix, then I can say it will give me a Q symmetric matrix. So now it is the basic definition of, sorry, not basic definition but the basic fundamental concept in the linear algebra. So now here the S is defined as A plus A transpose. So I can say here S is symmetric. So let's write it here. S is symmetric matrix, and here difference D is defined as the subtraction of this A minus A transpose. So I can say D is here Q symmetric matrix. So now let's look at the option. Option A says both S and D are Q symmetric. No, it is not the correct. Option B again both S and D are symmetric. Again not correct. Option C, S is Q symmetric and D is symmetric. The order is reversed. In the option C is also wrong one. Option D says S is symmetric and D is Q symmetric. Yes, it is the correct statement based on this concept. And now again let's quickly recall the definition of symmetry. If I am symmetric matrix, if I am taking the transpose of any matrix, and if I am after getting the transpose I am getting the same matrix as it is, then I am calling it as an symmetric matrix. I hope you already know this concept. And if I am taking the transpose of any matrix and if I am getting the negative of initial matrix, then I can say the matrix is skew symmetric here. So now option D is the correct answer for this question. Now let's move to the question number 9. Okay, question 9 says the matrix M. Okay, we have given matrix M and it has an order of 3 cross 3, has eigenvalue of minus 3 and 5. An eigenvector corresponding to the eigenvalue of 5 is given in this vector form. One of the eigenvector of a matrix M to the power 3 is. Okay, so they are asking about the eigenvector of this matrix M cube. So now here we have to recall the property of eigenvector here. If I am taking the any power of matrix and the initial matrix here M has any eigenvector, let's call it V, then after taking any power the eigenvector is remain as it is, but the eigenvalue is changed. So here if suppose let V is eigenvector eigenvector of matrix M, then V vector is also eigenvector for matrix M cube or M to the 500 or M square plus 3M plus I or M to the 50 plus 10M to the 5M plus in the any form. If I am performing some, if I am making some equation with the help of this A, then the eigenvector is remain as it is and etc. Whatever it may be in the form of this any equation, the eigenvector is remain as it is irrespective of this equation. But here the key point is that the eigenvalue is keep changing. It is depend on this function. So here the eigenvalue will rise with the power 3. If let's write here, if lambda is eigenvalue of matrix M, then lambda to the cube is eigenvalue of M to the 3. In the same way, lambda to the 500 is the eigenvalue of M to the 500. In the same way, I can replace this M square with lambda square and it's again give me the eigenvalue for this matrix. And again I can replace this M with the lambda and again it will in this identity with 1 and again it will give me the eigenvalue for this matrix. Here recall this polynomial, it's at the end it will give me a matrix after the addition and the rising power, it's give me a single matrix. Again here it also give me a single matrix. It's look like equation, but after finding the square and adding 3 times initial matrix plus identity matrix, it's give me a one final matrix. In the same way here it is also give me a same final matrix. So the eigenvalue of this matrix is exactly same as putting the lambda here at the place of M. It give me the eigenvalue of this matrix. So now here the eigenvector is not changing by making the any power, and that is what they are asking in this question. They are asking about the eigenvector, not eigenvalue. So the of course one of the eigenvector for this M cube is this one, same as it given in the question. So now you can see option C contain the same vector which is given in the question. So also this is going to the eigenvector for this M cube 2. So this is the correct answer for this question. So now let's move to the last question for this video. Okay, now let's solve question number 10 and which is the last one for this video. So question 10 says if a matrix, we have a 2 cross 2 matrix and we have B matrix which is again 2 cross 2 matrix, the transpose of product of the two matrices. On the other one, we have to take the multiplication of these two and we have to take the transpose. So now first of all let's do the multiplication and then we are going to take the transpose of it. Here again we have not need to find the all entries because here the option are present. So if we find the one entry and we can compare with the option and we can select the correct answer. So first of all let's find this first entry here in the multiplication. So here this 2 multiplied with 4, so 8 plus 20, so I am getting 28 as first entry. So now look at the option A may be the correct, option B also may be the correct, option C has a entry as 90, it is not the correct one, and option D has an entry of 48, again the option D will cancel out. So the only the two options are remain. So now let's, now the smart thing is that we have to find out the this entry, because here you can see this entry or otherwise this entry, because if you find this entry then the 90 is there in the both question, so we are not uh, approaching to our final answer. It is the waste of time to find this element because the both has the same entry. So now either we have to find this element or this element. So now remember we have to take the transpose. So if I want to find this element, then in this multiplication I have to find this element, because after taking the transpose I have to take the transpose of it to reach the my final solution, and the option are given after taking the transpose. So if I am taking the transpose of this one, then this entry will come here, and which is given in this case is 34 here in the option A, and option B has 48. So I have to find this entry in the multiplication to reach this entry in the transpose. So let's find this entry. So here uh, these two multiplied with 6, so 12 plus 4 multiplied with this 9, so 36. So now let's do the multiplication. So what we are getting is 48 here. So now if we take the transpose, this 48 will come here at this place. So now look at the option. Option B is the correct. Option B has the correct value. Here 28 and here 48. But option B has here given 34. So option A is again cancel out. So option D is the correct answer for this A multiplied with B and taking the transpose. So that's it. We have done. We have solved the 10 question in this video. And thanks for watching this video. Take care of yourself. See you later in the next video. Bye bye.